Hey everyone, this is Reshma from Edureka, and in today's session we'll be learning about OpenStack Cloud. Thank you all the attendees for joining today's session. If you can all hear me properly, please drop me a confirmation on the chat window so that I can get started. Okay, so Suman says yes, Jasmine says yes, and I've got a confirmation from the others as well. So let's get started. So let us look at the topics that we'll be learning today. So at first I'll tell you about cloud computing virtualization concepts so that you are very clear when I talk about OpenStack Cloud. After that, I'll tell you about the different cloud services and different types of cloud. We'll learn what is OpenStack, and we'll also take a look at the OpenStack architecture. We'll also see the OpenStack community and different OpenStack cloud deployment models. And finally, I'll tell you how to set up your OpenStack infrastructure by taking you through the OpenStack Cloud Design Guide. So is the agenda clear to everyone? Okay, so Suman says yes, Jasmine says yes, Mahesh says yes. So let us now begin with the first topic, which is cloud computing virtualization. Now, we're talking about cloud services, but what is actually a cloud and how is it created? You must know all of these prerequisite things if you're trying to actually build your own cloud infrastructure with OpenStack. So when you're setting up cloud, the first thing you need is basic hardware. So now there are bare metal servers running somewhere around the world. So what you do on top of this bare metal servers is that there is a layer of hypervisors. Now you can use any kind of hypervisors for virtualization purpose like VMware, Xen, Hyper-V, KVM, etc. So what this hypervisors does is that they enable virtualization. Now with virtualization, what you can do is that you can split up the computing capacity or the server capacity of your server, which is your bare metal server or your basic hardware. Okay, so Suman is asking what is a hypervisor? So, well, Suman, a hypervisor, as I was telling, is this can be either a software or a hardware that enables virtualization. Okay, so this is what we use to set up a virtual environment. This can be termed as a virtual machine monitor. So it runs on the host machine. So the machine where you install your hypervisor is called your host machine, and on top of that you can install different guest operating systems which can be termed as virtual machines. So does that answer your question, Suman? Okay, so she says yes. So like I was telling you, you can use hypervisors for virtualization purpose, and what virtualization actually means here is that this is the logical partitioning of your computing capacity of your server, your bare metal servers or your basic hardware. Okay, so let's say that I have got one server and I want to launch 3 instances, and instances here are nothing but they are virtual machines. So they might be of different operating systems, or they all can be Ubuntu machines. Maybe one of them is a Red Hat machine, the other ones are Windows. It can be like that also. So if you want 3 different environments based on just one hardware, you can do that. What you have to do is that you have to enable virtualization to create logical partitions. Well, however, this can also be done in the alternate way. Let's say that you have got 3 servers and you want to perform some high computing that needs a lot of processing power. So let's say that you're working on something that needs a lot of processing power. So you are actually taking 3 hardware servers and you are enabling virtualization to create only one instance so that it has a lot of computing power. So you can do that with virtualization as well. And if you want to give me a virtualization example that you can relate to, I'll tell you that you can consider your laptop or your computer which you are actually working on right now. So what it has is that it has a basic hard disk, right? But what happens is that when you open up your computer, you see that they are divided into different local disks. You have got your local disk C, D, E, F. So these are nothing but virtualization that enables logical partitioning. But actually in your computer, there is just one hard disk. So this is a very good example of virtualization that you all can relate to. So now what happens is that these are the consumer, these are the people who actually wants to use services. So what they do is that they make a request to the IT department, and this IT department is responsible for maintaining and for support of this cloud's infrastructure. So what they do is they maintain the metal servers, they maintain the hypervisors and the instances that are launched on top of it. So the consumer makes a request to the IT department, and the IT department somewhere here has an admin. So what the admin does is that admin takes a look at the request and approves it if it meets all their needs. And finally, the consumer gets all the available instances or whatever he requested after the admin approves. So this is how you actually avail cloud services in real life. And when I'm talking about availing cloud services, what actually happens and how it actually connects to everything, I'm going to tell you right now. So this is the consumer again that makes a request to the cloud, and somewhere over here the admin is there. So basically what the consumer wants are computing resources. So the admin, who is actually managing the entire cloud infrastructure, approves and gives them access to the compute resources, and they use southbound APIs. So the southbound APIs are used to connect different layers in the cloud service stack. So the APIs connect you with the compute resources on which you can work on, you can develop your applications on, and some more southbound APIs are used for storage purpose. Now this part can be termed as your hardware part, because eventually everything gets stored in a hardware, right? So this is the abstract pool of storage resources, and these are all connected using APIs. They can use both southbound and northbound APIs for different purposes, but while they're connecting you to it, they're using southbound APIs that connects the top layer to the bottom layer. Is the slide clear to everyone? Any questions? Okay, no questions? So now let us move forward and take a look at the different cloud services. So this is the cloud service stack that you see. So on top of this, there is the data, application, runtime, middleware, operating system, virtualization, server, storage, networking. So the bottom three layers can be actually termed as your hardware, your servers, your storage, your networking. For networking, you might be using devices like routers or switches. For storage, you might be using disk and bare metal servers. And on top of that, there comes the virtualization part, your hypervisor part. Then on top of that, you can install an operating system. There can be different middleware like RabbitMQ or JDBC. So middleware are nothing but they're computer software that provides service to software applications beyond those that are available from the operating system. So this can be, the middleware can be actually termed as a software glue, and it enables communication and management of data in distributed applications. Okay, and a very good example are the RabbitMQ or JDBC. These are very good examples of a middleware. And in runtime, you have different softwares like data recovery software products, etc. And finally on top of that, this is the application that you have. This is going to be your application, or maybe some other software or application that might be running on your cloud infrastructure. And finally, the data that you use in your application. So this is a basic cloud service stack. So we'll take a look more about it when I tell you about the different infrastructures, okay? Okay, so now we'll take a look at infrastructure as service, platform as service, and software as service. Okay, so when you have infrastructure as service, this is the same cloud service stack that I just talked about. So when you are availing infrastructure as service from your cloud vendor or your cloud provider, so what happens is that this part, the networking, storage, service, and virtualization part is completely handled by your cloud vendor. And after that, when the cloud vendor sets up these things, it gives you the basic hardware and the hypervisors. And after that, this is something that you should manage. You can actually install your own operating system, middleware, runtime applications, and data. And OpenStack actually provides you with infrastructure as service. Similarly, in platform as service, the cloud vendor provides you till runtime. It gives you all the services that you need for runtime, starting from the hardware to virtualization. You can also request your own operating system. They'll give you that, the required middlewares, the runtime softwares, and after that, you can just launch your applications on it. And a good example of platform as service is also AWS. Well, AWS can also be an infrastructure as service, but you can also request it as a platform as service to develop your applications on. And finally, there is software as service. Now in software as service, almost everything is managed by the cloud vendor itself. The application is also run by the cloud vendor itself. All you have to manage is the data in it. Now, all the Google services, the Gmail that you use can be termed as software as service. You're using the software, the application is running on their server, you're just managing the data on there. So when you're availing these services from the cloud vendor, there is a pure abstraction. Customers do not need to worry about the servers or anything. The cloud vendor manages all by themselves, and you can just focus on running your application on it, because that is why you need a cloud infrastructure, right? So any doubts about infrastructure as service, platform as service, or software as service? Shall I move on? Okay, so let's move on and take a look at the types of cloud. Okay, now there can be broadly 3 types of cloud. We can have a public cloud, a private cloud, or a hybrid cloud. So let us take a look at them one by one. So let's see what is a public cloud. So this is you who is trying to access to a public cloud, and this is your service provider cloud. This is the public cloud that is managed by a cloud provider or a cloud vendor. So what you have to do is you have to go through their firewalls. So these are all the security protocols. So there would be authentication when you try to go through the firewall to access the cloud infrastructure. So what happens in a public cloud? So let's say this is you who is trying to access resources that is present in the public cloud. So this is the cloud that is managed by your cloud provider or your cloud vendor, and you are trying to access service from it. And there is the firewall. So if you want to go through that firewall, you have to go through certain authentication processes to avail all the resources. So you have to go through the firewall, and there you'll find all the instances that you want to use that is on the other side of the firewall. So all the instances and all the security protocols are all defined by your service cloud provider or your cloud vendor that you want to access. So everything is just there. You just have to go through an authentication process, buy services in order to do that, and avail all the resources. So everything in a public cloud is managed by your cloud vendor, and you can only avail services from there. And again, a very good example are Microsoft Azure or AWS, so they are public cloud infrastructures. Now let us take a look at a private cloud. Now what happens in a private cloud is that it is an on-premises cloud. If you're running a big enterprise and you don't want to rely on a different cloud vendors, what you can do is that you can set up your own cloud. And obviously that's why we're using OpenStack, and OpenStack is widely used for that purpose only, for setting up cloud infrastructure in enterprises. So this is your on-premises cloud infrastructure, and you have got all the instances available to you. But to protect it from vulnerability from a public network, you also have to set up a firewall. Okay, so this is your private cloud that is completely inside your own network, and you have defined a firewall so that people from outside the public network cannot access it unless they're authorized to do it. And finally, there is hybrid cloud. So as the name goes, it is a mixture of a public and private cloud. So let's say that this is your on-premises cloud infrastructure, or this is your own private cloud, and you want to access some of the public cloud services as well. Let's say that you're running production on your on-premises cloud, but for development or testing purpose, you want resources that are present on a cloud infrastructure. Let's say that you're running your production on your on-premises cloud or on your private cloud, but for your development and testing purpose, you want resources from a public cloud. So what you can do is that you can set up a secure VPN tunnel, and this is a virtual private network tunnel. Now this is very secure that you can set up to connect your on-premises private cloud to a public cloud and create your own secure hybrid cloud. And you can also actually move instances from your public cloud onto your private cloud, or from your private to your public cloud through your secure VPN tunnel. And these security protocols can be purely defined by you, so that you have full control over, who can access this data, and that it is fully secure when you're transferring data from a private to public or from public to your private cloud. So these were the types of cloud, a brief overview of a public cloud, private cloud, and hybrid cloud. Okay, so Vikram is asking which is private and public in this. Okay, so this service provider cloud, this is your public cloud, and on-premises cloud, this is your private cloud over here, and a mixture of this, a little bit of this and a little bit of that. Actually, you can create a secure hybrid cloud, and you can make a connection between these two clouds by creating a secure VPN tunnel and create your own secure hybrid cloud. So is that clear to you, Vikram? Okay, any example? Yeah, of course, I just gave you an example, but I will repeat it again. So on-premises cloud is your own cloud infrastructure that you set up within your company's infrastructure. This is your on-premises cloud. Your data centers lie in your own premises or in your own company, and you have set up your own cloud infrastructure. But let's say that I'm using a software and I'm only using this private cloud for my deployment purpose of my application. But the actual development and the actual testing are taking place on an AWS cloud infrastructure, okay? So for that, when I want to deploy that, I need to transfer all the data from the development environment, from the testing environment into my on-premises cloud or into my private cloud, right? So that I can deploy it. But there might be sensitive data that I don't want anyone to access it. So that's why in order to transfer from my AWS to my on-premises cloud, what I'll do is that I'll set up a secure VPN tunnel. Now this is my own virtual private network. So I'll define my own security protocols according to my data or according to my company policies, and a mixture of these two will actually create a secure hybrid cloud. So this is also an abstract form, and this secure hybrid cloud will actually contain everything, all the development and testing data and the deployment data or environment also. Is that okay, Vikram? Okay, so he says, all right. Okay, so now let us see what is OpenStack. Like OpenStack organization says is that OpenStack is a collection of open source technologies delivering a massively scalable cloud operating system. So with OpenStack, like I told you, you can set up your own cloud infrastructure, and it provides you with infrastructure as service, and it provides you with a lot of services. And these are the services over here: Keystone, which is the authentication and authorization service; your Glance service, which is used for storing images, and images here means the different types of operating system files. And there is the Nova, which is the computing service. This is where you can actually launch up your instances and work on those instances. You have the Neutron service, which is the networking service that connects all the services to each other. You have Swift for object storage, Cinder for block storage services, Horizon, which is your dashboard, which easily helps you to provision all your application developers with different instances and manage your infrastructure as a whole. You have got Celometer, which is used for metering purposes or billing purposes, that keeps a track of uptime of different instances. And then you've got Heat, that is used for orchestration purpose. So we'll be learning more about OpenStack and how to set up your cloud infrastructure in a while. So any questions still here? Well guys, let me tell you that you can ask any questions at any time. I'll be happy to answer your questions. So do you have any questions right now? No questions. So now let us take a look at the OpenStack architecture. So this is the OpenStack cloud architecture. So let's consider that you're accessing OpenStack with the dashboard. So the first thing that you'll see when you start OpenStack is the dashboard, which is the horizon. And this virtual machine is the core part. So this is where everything is happening. So this is just a graphical user interface, which is horizon, which is the dashboard. So what it does is that it is directly connected with Neutron, which is the networking service. Now Neutron is actually connected to every other service because this is what actually enables communication between different services. So the Neutron connects you to the virtual machine. And let's say that you want to perform some kind of computing in your virtual machine. So as I told you just now that you actually do all your computing with the Nova service over here. So this is where you launch up all your instances. And to launch up your instances, you have to boot it from an image. You have to have an image from which you can actually launch an instance. And all the images are here in Glance. So the Glance helps you to launch your instances. And all the images are actually stored in database. So when you request for a computing instance, what happens is that Glance actually retrieves it from the database, then Glance over here actually launches the instance, and it is launched in Nova, and it finally provisions the virtual machine or your machine with the computing instance that you requested for. And while you're computing, and if you want to store some data, so these are all directly linked to Swift, which is used for object storage, and Cinder, which is used for block storage. Cinder over here can be actually thought of as a pluggable storage device, and Swift is your object storage where everything is actually converted and stored as an object. So Ceilometer here actually monitors everything. The keystone over here is used for security. So the first thing that will happen when you are accessing the dashboard is that it'll ask for your authentication for your username or password, and that is what keystone actually does. So it sees that whether you have the authorization to perform any tasks that you want to do in your OpenStack, and the heat over here which lies on top of it actually controls all the orchestration about how different components are actually communicating with each other and what is going to be the order of tasks. So like I just told you, at first Glance will retrieve the data from Trove and it will launch up an instance. After that it's going to Nova, and finally it's going to provision the VM with the instance. So this is what heat takes care of. It orchestrates all the services together. So any doubts on the OpenStack Cloud architecture? No doubts? Now let us talk about the OpenStack community. Well, OpenStack is an open source project, and a lot of people are actually contributing, and by contributing I mean that they are contributing code to OpenStack. So these are the different services, and this is a pie chart of that. So these are some other services also that people are contributing. There are a lot of outside contributors for Nova and for different configurations, project configurations, Neutron, Tempest, Keystone. So these are the services that are available in the previous versions as well. So now the latest version is Okata. Before that, that was Newton and Mitaka, and maybe finally after a few months they're going to launch another new version. And the fun fact is that they actually name all their different versions or their different releases in alphabetical order. So at first it was M, Mitaka, then N, Newton, then finally it's O, which is Okata. So I don't know what's going to come with P. Does any of you guys know what is going to be the next release that's going to start with P? Okay, so Vikram knows it's called Pike. And then Queens. Very well, Vikram. Thank you for letting me know that. This is the pie chart of different companies that has been contributing to OpenStack. And OpenStack, let me tell you, was actually created first by Rackspace, which is a cloud hosting company, and NASA. Yeah, the NASA which actually sends people to space, that NASA. So they created OpenStack first in 2010, and they made it open source, and since after that, HP has been contributing a lot to OpenStack, almost 24% of it. There is VMware, and there is IBM, there is Red Hat, there is Mirantis, some different independent companies, and there are actually even more companies that are contributing right now. There is Dell, so they are all in others right now. So you can say that the open source community is actually very huge. And by the numbers, if you see that there are 1,202 contributors, Samsung, Yahoo, Comcast, which are one of the big giants in the tech industry, are among the top 20 users of OpenStack. There are 350 new features launched recently. So there are 53 third-party cloud integrations, and the top companies are these that are committing code every day now and then. there is 32% increase in the infrastructure, and the code is written in 16 different languages, and there has been almost 2,902 bug fixes. So yeah, so there are a lot of contributors and there are new features coming out very frequently. So now let us take a look at the cloud deployment models. Now you can deploy your OpenStack Cloud in one of these 5 ways. The first one can be your on-premises distribution. It can be an OpenStack-based public cloud, a hosted OpenStack private cloud, a OpenStack as a service, and appliance-based OpenStack. So let us take a look at them one by one. So the first one is an on-premises distribution. So let's say that you have an enterprise and you want to actually set up your own private cloud infrastructure. So on-premises means within premises or within your own company premises. So this is where you can use the OpenStack software to actually set up your own private cloud infrastructure. And the next deployment model is the OpenStack-based public cloud. So what happens is here there is a cloud provider or a cloud vendor, and it actually sets up his own cloud, which is a public cloud, and he actually sells different services. He's actually selling services maybe to avail instances. Someone is asking for storage. So a cloud vendor has actually set up an OpenStack project and has made it a public cloud, and he's allowing people to access services from there. So that can also be a way of using OpenStack. So the next is a hosted OpenStack private cloud. So what happens here is that your cloud vendor actually sets up your own private cloud. So if you don't want to take the hassle of actually creating your own private cloud infrastructure because you have other things to focus on, you can actually ask one of your cloud providers. They will actually set up all the OpenStack infrastructure in your premises to set up your own private cloud, and they will only charge for support, maintenance, and for initially starting up your own private cloud infrastructure. The fourth is OpenStack as a service. So what happens here is that a cloud vendor actually sets up everything. He is using his server, he has set up an OpenStack, and you were just using services. So this is for small projects or small applications that you want to run on. If there is a person who has actually set up an OpenStack, let's say that he'll give you maybe an OpenStack sandbox or something. So one example is the tri-stack that you can use if you want to just launch 3 instances and you just want to like go through OpenStack. You can use that, which is a sandbox. So this is an example of OpenStack as a service. So your cloud vendor sets up everything and you can just access whatever they have installed in their system. So they'll give you the access for that. And finally, there is appliance-based OpenStack. So this is, appliances are software that actually do not require an operating system. They'll run directly on servers. So if you're using infrastructure as service and you want everything under your control, you can use this kind of a deployment model also. So any doubts on the deployment models? No doubts? Great. And finally, let us take a look at the OpenStack Cloud Design Guide. So if you want to set up your OpenStack infrastructure, I'll show you different scenarios, and I'll also let you know about the different resources that you might need, things that you need to focus on while you're setting up your cloud infrastructure. So you might need a cloud infrastructure for general purpose. You might need it for computing purpose, that is just focused on computing. You might be needing it for storage purpose, which is storage focused. You might be needing it for multi-site projects, or maybe you want to set up a hybrid cloud infrastructure. You should also take a look at the security and legal requirements, and also if you want a network-focused cloud infrastructure, I'll tell you the guidelines that you need to follow, things you need to focus on when you want these kind of cloud infrastructures, okay? So the first one is general purpose. So general purpose can be, let's say that you have a small application and you want to run dev, test, prod on your cloud infrastructure, which is not a very large application. So these are the resources that you might be needing. So you would be needing a VM disk image library, and this is actually a file format that describes containers for virtual hard disk drives, which you can use in virtual machines like a VMware workstation or a VirtualBox as well. And raw block storage means that these are storage areas and they are divided into different blocks, and each block can be actually controlled as an individual hard drive. You might need a file or object storage, and if you talk in OpenStack terms, you would need the Glance service over here, you would need the Cinder service over here, and the Swift service over here. And obviously, since you have a cloud infrastructure, you need a firewall to protect it. You might need load balancers, so you can also actually avail LBAS, which is known as Load Balancer as Service from OpenStack, and different software bundles, of course, to develop your application, like different software development kits or related other softwares that you might actually need. So any questions over here? Okay, no questions. And now let's say that you want a complete compute-focused cloud infrastructure. So what you might be needing is that you might need to perform high-performance computing. So for that, you might be actually dealing with a lot of data and you need a lot of processing power. So make sure that you actually avail large instances in your OpenStack infrastructure. If you need it for high-performance computing, you might actually want to also make an analysis of that data. So you might want to use big data analytics using Hadoop. So make sure that you have a cloud infrastructure which avails you for analysis purpose as well. And also you want to use different tools like Jenkins for a continuous integration and continuous deployment of your application. And when you're actually focused on just computing, you want to use it as a platform as service and not as an infrastructure service, because you don't want to worry about the lower layers. You are completely focused on computing and processing of your data, and you might need signal processing for NFV or the network function virtualization, which is actually a key enabler of a programming network and infrastructure foundation. Next, if you just want to focus on storage, you might need storage for archiving your data and you want to store it in a particular hierarchical manner, and you want to actually synchronize your data as well. Again, you want to maybe perform data analytics and you want to analyze your data that you're storing. So let me tell you, if you're completely focused on storage, you can use high volumes of storage from Cinder, or you can actually define your containers in Swift Object Store as well. So you need a persistent block storage, which is obviously Cinder, and you also might need it for operating system and image storage, which is your Glance service where you store. So make sure that you actually avail a lot of memory to your database to store that amount of information, because it's a complete storage focused infrastructure. So make sure that you actually purchase or use a high volumes of storage memory. And you might need it for media streaming, define databases, like you have also got the database service known as Trove. So make sure you avail all those services when you are completely focused on storage. Now let's say that if you want a network focused infrastructure, what you might need be setting up is you might need to set up network management functions, network service offerings. You might want to set up different web portals or use different web services. And since it's a network focus, you want to communicate with the other parts of your infrastructure. And since it is a network focused infrastructure, obviously you want to communicate with other parts of your infrastructures. So you might want to focus on setting up a video conference or web conference, voice over IP, and you want to transfer lots of data from one part to another. So make sure that you have a good setup for a high speed and high volume transactional systems. And also make sure that the security is well defined so that there cannot be any vulnerabilities or any attacks while you are actually transferring your data. And next you might need a hybrid cloud, and this is in situations, let's say that if you're working in an e-commerce website and out of a sudden, let's say that you decide to hold a mega sale. So obviously you'll be expecting a huge amount of traffic and huge amount of requests coming. So for that you might need different load balancers, more servers. So that process is known as bursting, and in situations like that you might want to avail load balancers or servers from a public cloud. So that is when you should actually think about bursting private into public to avail more servers or more load balancers to use for a particular amount of time. Because after that sale, maybe you might not need that many load balancers or that many servers to handle requests, because after the sale is over, the amount of requests, the traffic is going to actually go down or become less. And then maybe you want some other servers for disaster recovery purpose. And by this, I mean for backup, right? So let's say that you have got data center servers that are on premises in your enterprise, but for backup, let's say that you have stored all those data in a public cloud. So for that also, you might need a hybrid cloud for development and testing. And like the example I just gave you, let's say that you're just only running production on your private cloud and development and testing is actually happening on a public cloud. A federated cloud, which is a cloud that is defined, infrastructure that is actually defined to meet all your business requirements or support legacy systems. Legacy systems are nothing but they are old methodologies or old computers that is actually going on and you don't want to maybe change it. So if you want to support those kind of methods of computing, so you might also use a hybrid cloud. So there is a cloud, your private cloud is actually working on new technologies and new procedures, while your other processes are in a public cloud, which you have defined totally in a hybrid cloud, are running on legacy systems. And let's say that if you have a multi-site project, so you have a company that has got offices in different locations around the world. So, and if you're dealing with sensitive data, and if you're worried about data locality, because there can be data sovereignty issues with a public cloud, since let's say that if you are in India and you're storing some kind of data in AWS, but the server that is actually storing your data maybe in United States, and sometimes when you want to take out all that data, there might be data sovereignty issues that you might face. So it's better that you actually define your own OpenStack cloud infrastructure so that you don't get such issues. And for multi-site projects that have people working from all around the world, it is very essential that you use an OpenStack infrastructure to create your own private cloud infrastructure, and you just give authorization to the people who can access your cloud infrastructure. And finally, when you are actually setting up your cloud infrastructure, make sure that you go through all the security and legal requirements, the different contractual issues, the third-party involvement, your data location of your servers. So maybe you should consult with a lawyer for this. So make sure that you go through that so that later on you don't face with any kind of legal issues. So this is a brief overview of an OpenStack Cloud guideline. So any questions on that? Any question that you want to ask me about this? Okay, no questions. So this is the web browser of my virtual machine. This is where I have installed OpenStack. So I'm just going to go ahead and launch the dashboard, which is Horizon. So I'm going to go to this IP 10.0.2.15/dashboard and enter. So this is the first thing you'll see when you are trying to log into the dashboard. It will ask for a username and a password. So I'm going to log in as admin and the password. So let me tell you that you can find the password in the root directory in the file keystone_rc_admin. So that is where you'll find the password for the admin user. So I'm going to go ahead and click on connect. So this is my dashboard. I have successfully logged into Horizon. So you can see there are a number of tabs over here. There is this projects. So the project is the demo project, the admin, and different services. You can go ahead and check the users. So these are also basically the demo users, the different services, and of course the admin as well. So there you can see. So you can also define groups and different roles to a particular user. So this will have all the authorization of a particular user, so you can assign roles to a specific user. So let me just show you how to create instances and assign them with networks in your OpenStack Cloud. So let us first go to Network, click on Networks over here, So you can see that there is already a public net defined with a subnet also. So you can think of it as an external network. So we're going to go ahead and create our own networks. So for that, go to this tab over here, click on it, write a network name. I'm going to name it Edureka Net. Make sure you click that dialog box here, create subnet. Then assign a subnet. I'm going to name it EduSN. Provide with a network address. I'm going to give it 192.168.1.0 and slash the CIDR notation /24. Click on next. You can choose to enable the DHCP and don't bother about filling out these. So just go on and hit the create button. So there it is. You have created a network which is Edureka Net with a subnet EduSN. So this is the IP of your subnet and your network. Okay, so now let us create some instances. So you can go ahead and check the glance repository. I'll show you where that is. Just click on compute and images. So you can see that you have a Ceros image already. You can add image over here on to create image. You can add an Ubuntu image or CentOS image or whatever image that you want to boot up your instance from. So I'm going to use the Ceros only. So I'm going to go ahead and click on the launch button over here. So this will ask for the details of your instance. So I'm going to name it Edureka VM. The availability zone will be Nova. This is the compute zone. And you can also mention how many instances you want of this kind. So I'll just let it stay as 1. So note that there are some asterisks marked on these options. This means that these are mandatory to fill out. You can also leave out security groups, network ports, key pair, but you should fill out the details, the flavor of your instance, and the network. So we'll directly jump on to flavors. This is the mandatory one. So now you have to choose the flavor of your instance among these. Now flavors are nothing but the disk size and the RAM size of the instance that you want to launch. So I'm going to go ahead and select on m1.tiny. So this has 1 vCPU, 512 MBs of RAM. The total disk size is 1 GB and root disk is 1 GB. So I'm going to go ahead and create a tiny image. So I'm going to select the M1 Tiny. So these are predefined flavors that are already there in OpenStack, but you can also go ahead and create your own flavors as well. So now click on next. So now you have to assign your instance to a network. So we have just created the Edureka Net with the Edu subnet. So I'm going to assign this network to my instance. So I will click on this button over here. And now you're ready to launch your instance. So click on Launch Instance. And you can see the message that one instance was launched. And you can go view your instance, and I'll tell you where you can go ahead and see your instance that you have just created. So go to Compute and go to Instances. So there it is. So this is the VM that we just created. This is assigned with the IP address 192.168.1.10. The size is M1 Tiny. This is the flavor. The status is active. So this is up and running. So now let us just go ahead and click on my instance. And when you do, you can also have an overview of your image. This will have all the details about your instance. You can also go to the console and use the terminal of your instance. And this is the terminal of the instance that you just created. So I'm going to go ahead and log in. So the username is Ceros. And the password is over here. It's Cubswin. So here it is. So this is your instance that you can use it for any purpose that you want. You can launch as many instances that you want. You can define flavors in your instance. You can also define the image where you want to boot it up from. Now this is a Ceros image. You can also launch Ubuntu, Linux, Red Hat, any kind of instance that you want to. So this is what you can do with OpenStack, and this is how you can design your own OpenStack Cloud by creating instances and networks. So let me just show you how our network topology actually looks like. So just go to Networks, go to Network Topology. It's better if you see it in a graph. So there it is. This is our instance. You can also toggle the labels if you want to see the details of the icons that is in front of your screen. So this is the Edureka net that we defined, and this is the instance that we created, and this is our public network. You can also connect your instance to the public network or any other network that you have created in your OpenStack Cloud. So you can do more with OpenStack. You just have to install it. It is open source. You can get it for free and start your project and start using a cloud infrastructure with OpenStack. So I hope that it is clear to you. Any questions? All right, no questions. So this is what we learned today. We learned about different cloud virtualization concepts, different cloud services. I have told you about different cloud deployment models. We have learned what is OpenStack. We have taken a look at the OpenStack architecture and OpenStack architecture design guide finally. So do you have any questions on these? You can still ask me. Okay, very well, no questions. Thank you guys for joining today's session. If you have any questions or any doubts or any kind of feedback that you want to give me, kindly drop it in the comment section below, and I'll see you next time. Till then, happy learning.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!